Alright everyone, so here is an example that we didn't get a chance to cover in class just due to time, but it's about finding the volume of a solid where we're going to revolve the region around a vertical axis instead of a horizontal axis. You can read the statement of the problem right there. It says consider the region bounded by y equals x squared, y equals 2, and the y-axis. Find the volume of the solid formed by revolving this region about the y-axis. So what's different here is that we're obviously revolving it around a vertical axis, as I mentioned before, as opposed to a horizontal axis. This is sort of similar to when finding the area bounded by two curves. We took our rectangular slices to be in a different direction than we have normally done. So we'll see how this is formed. If you think you might have an idea of how this works, I advise, or I would suggest pausing the video, trying to work out as much as you can by yourself, and then you can always come back and watch and see how you did, or from where you got stuck, or how you could proceed. So let's get a clean page here and see if we can figure this out. So let's first start by sketching the region. So okay, there's our xy axes here. Now, of course, with the parabola, we have a part in the first and second quadrant. But since we're revolving this around the y-axis, and there is symmetry with this parabola, we don't need to revolve both the first and second quadrant pieces around the axis, around the y-axis. We can just revolve the first quadrant piece, and it'll sweep through the same volume that both pieces would. So we're going to limit our discussion here to just the first quadrant piece. Okay, there's our y equals 2, and that looks kind of sloppy, but we'll have to deal with it. So it's this region here that we're going to be revolving around our y-axis this way. And since we're revolving in this direction here, we're going to have to slice the region up a little differently. So instead of drawing vertically oriented rectangles, we're going to draw some horizontal rectangles, which are going to look something like this. And notice our little slice here is going to be a delta y, or have a width of delta y, as opposed to delta x. So there's our first indication that we're going to be integrating with respect to y instead of with respect to x. So we're going to need all of our equations and whatnot relating y values, y in terms of x, as opposed to our usual way. So now when we revolve this around the y-axis here, if you were to look at the cross-sectional piece, we would get a cross-section that looks circular. Now I know that doesn't look like a circle. I'm trying to give some perspective as if you were able to see just a little bit of that top part here, with the axis coming down this way. Okay, you're not standing directly overhead, so you're kind of at a skewed orientation to it. But that's what the slice looks like, and we could see, I hope, that this length right over here, this length is going to be the radius of the circle. So as always, to find the area of a circle, we are going to use our pi times the radius squared. And so we just got to go back to our original function here and try to figure out what the radius is in terms of the function. Well, since we're looking at a horizontal length here, the radius that we are considering is that side length of the rectangle. And that side length of the rectangle is going to be given by a difference of x coordinates. Okay? And remember, to find horizontal length in the xy plane, we always take the greater function minus the lesser, or right minus left. So we're going to take the right function to be the parabola, and the left function to be the y-axis. Okay, but remember, we have to do this y in terms of x, x in terms of y, as opposed to y in terms of x. So I need this parabola to be written in terms of y. So right now I know this is y equals x squared, so I need to solve this for x, and of course when we solve this for x, we get plus or minus the square root of y. Let me back out of those two marks. We get the square root of y. Now since we're only using the right half of this parabola, we only need the positive root because we're in with positive x and y values that we're using here. So we'll let x equal the square root of y, and that's what our curve is, okay? And that's going to be this right edge over here of the rectangle. As we said, the left edge is the y-axis, but the y-axis has the value of x equals 0. And so then we're going to use, I'm going to make a little side note here. This is the right, and this is the left. So again, it's right minus left. And so the radius that we're dealing with here is going to be the square root of x. I'm sorry, the square root of y minus 0, or just the square root of y. And so the area of our cross section, which is a circle, is just going to be pi times the square root of y squared, or just pi times y. And now in order to find the volume, we just need to integrate along the y-axis, that expression. So we're going to have pi times y dy. And remember, we're working along the y-axis here, so let's go back to the previous picture for a moment. So along the y-axis in this direction here, what are our limits of integration? Well, the bottom starts at 0 and the top ends at 2, and so our upper and lower limits will be from 0 to 2. And so going back to our integral, we'll go from 0 to 2. And then we just need, of course, to work that out. If we actually want to find the volume as opposed to just an integral that represents the volume, we would do this by saying, by taking the antiderivative of pi y, which would be just pi over 2 y squared, evaluated from 0 to 2. And then if we just substitute and evaluate 4, y squared, or 2 squared is going to be 4, divided by 2 is 2, so we're going to end up with a 2 pi. And then if we plug in 0, we get 0, and so that's minus 0, or just 2 pi cubic units of whatever the volume would happen to be. All right, hopefully you got that answer yourself, and if not, go back and review this as much as necessary to make sure you understand the process. Also, be looking out for more videos after this one. We'll do some other shapes, some more vertical axes, and some that involve washers as opposed to just discs.